Hi, this is Mrs. Ziegler, and I'm going to go over your nomenclature. So this is naming and writing chemical formulas for compounds, specifically ionic compounds and covalent compounds. And this will be for just type 1 ionic compounds. So the first things that you should be asking yourself when naming. Okay, so first thing is, these are the questions you should always ask yourself. First one is, what type of elements do I have? Okay, then you're going to ask yourself, how many capital letters do I have? Now, this is really only specifically for when you have more than the different types of compounds. So when you're asking this question, how many capital letters, for what we're doing, it's always going to be 2 capital letters. So when we have ionic compounds, so when you ask what type of elements you have, that means you have a metal, which is a group A metal, and a nonmetal. So when you're naming them, you name the first ion, which is just its name, the element's name. And then when you name the second ion, which is the nonmetal, it has the suffix, the IED ending. You remember when we were naming ions last semester, when we were talking about the different ions that are made from metals and nonmetals. So here's an example. I have NaCl. So the first thing is I'm going to name the metal ion, which again, the name of the metal ion is just sodium, its name. The second part is the nonmetal ion, which again has to change the name with the ending of IDE. So therefore it's chloride. So therefore when we name them, we just put them together, sodium chloride. Next example, I have MgI2. So again, Mg is just magnesium. I is iodide, so the name is magnesium iodide. So now we are going to do molecular compounds, which again, when you ask yourself what type of elements, they're going to only be nonmetals only, which again is the right-hand side of the periodic table. So when we name them, you have to remember for covalent compounds, molecular compounds, it has prefixes, and that's how you essentially know that they're compounds, that they're nonmetals, and that they're covalent. Prefixes mean that it is in the front of the name, and it gives you the number of atoms that are bonded together. So you name the first element. If it has more than one atom, you have to have the prefix. But you always have to have a prefix on the second name, which again has the ending of the IDE endings. So here are your prefixes that you have to know. So 1 through 10. So if you have 1 atom, that means it's going to be mono. If you have 9 atoms, that means it's nana. So let's look at examples. Again, if the first element has no subscript, then you do not need a prefix on that one. All right, so I have CO2. So first name is carbon. Okay, it doesn't have a subscript, so that means there's only 1, so I don't need a prefix. Okay, so it's just carbon. The second name has to have, again, the ending of IDE, and then it has to always have a prefix. So since there's a number 2, that means it's going to be oxide is the name of the ion, but then I have to add the prefix. So I have carbon dioxide. We'll do another example. So I have N2O4. Again, I need the prefixes for the numbers of atoms for each one. The first element's name is nitrogen. Second element's name, of course, is oxide. And then I need the prefixes. So it's dioxygen and then tetroxide. Now, when we looked at prefixes, it did say tetra. When you have 2 vowels next to each other, 9 times out of 10, you're going to drop the A and then keep the other vowel. So that's why it's tetroxide. Again, the best way to learn how to do this is through practice. Now we're going to write chemical formulas. So for ionic compounds, again, for the names, you just write the chemical symbols. Then you bounce the charges by using the crisscross method, or I call it drop and swap, depending on how you want to look at it. And then here's examples. So I have aluminum sulfide. So the first thing is I'm going to write the chemical symbols. Al for aluminum, it's S for sulfide. In this case, there's O for oxygen. I know the charge for aluminum is 3, so I crisscross it. I only take the number and I make it the subscript. For oxygen, it is 2, so therefore I crisscross. Or if you want to view it as whatever the charges are, you drop them you drop the charges down as subscripts, and then you swap their places. And this is the other way to look at it. Because the charge for for aluminum is a +3, and I have 2 of them, that would make a +6. Since the charge for oxygen and sulfur is a -2, and I have 3 of them, that'd be a -6. So a +6 plus a -6 makes it 0. That's how I balance out my charges. Another example. Okay, so again, chemical symbols, bounce out charges. So I have nickel for chromate. The 4 tells me the charge. This type of compound is what's called a type 2 because it is a transition metal, and whenever you have transition metals, you need Roman numerals. We did not learn this, but it is something that is good to know. Chromate, it does not have an IDE ending, so that means this is what's called a polyatomic, meaning it has more than one atom that's bonded together that have an overall net charge. This information will be given to you. You just have to really learn how to name or write formulas. So I write the chemical symbols. That's the first thing. Ni is nickel. Chromate is actually CrO4. Since it's polyatomic, I automatically put it in parentheses. The 4 tells me that that's the charge of nickel. Okay, so that's where I'm going to write the 4. I would look up the charge for chromate, which is a -2. Okay, so that's where there. When I have, because these are ionic compounds, I have to reduce. So since I can divide both of these by 2, this actually reduces down to 1 and 2. So this would be the correct formula for writing ionic compounds like this. This is actually called a type 2 and type 3 compound because it's a type 2 because it's transition metal, and it's a ternary because it has a polyatomic. Again, this is not something that you will learn, but it is something that's good to know for higher level chemistry. Now, for writing this is just, again, showing you a charge. Now, for writing for covalent compounds, again, same steps where you write the chemical symbols, but it's even easier for molecular or covalent compounds because the prefix tells you how many atoms you need. So here I've got carbon monoxide. So again, I write the chemical symbol C and O. Carbon is C, oxide is O. Carbon has no prefix, so I know that that's 1. Mono also has the prefix for 1, so that's why it's CO. Here's another one. Dinitrogen tetraoxide. So again, nitrogen is N, oxide is O. So the di tells me it's 2. O is the oxide. Tetra means that it's 4. I do not reduce these because, again, the prefixes tell me exactly what the subscripts are. If you have any questions, please reach out, but practice is the way that you will learn.